following video was recorded live at the conference and produced by the Sound of Knowledge Incorporated. Welcome to the Black Hat Briefings 1999. This meeting was held in exciting Las Vegas, Nevada from July 7th through the 8th. This is videotape number 25, Track B, towards a taxonomy of network security testing techniques.
I've been asked to remind you that this talk is being recorded. Our friendly cameraman back there. I want to say before I really get started that this is a work in progress. It's not, this is the way it ought to be. This is the way we should discuss it. It's an attempt to provide some language and some structure so that we can talk about vulnerability scanning tools in a better way. So I encourage you to give me feedback either in questions or afterwards about how to do this stuff better. Oops.
This is the Evelyn Wood speed version of the talk.
There we go. So I'm going to talk a little bit about who this talk is intended for, some of the goals of the work, what taxonomies are and why they're useful, why I'm doing this, and then talk about the two big classes of testing that, the way I think about them, which are exploit testing and inference methodologies. So the main audience of this talk, the reason I think many of you are here, is because you use security scanners and you're frustrated by them because they work the way you would expect them to work. You'll expect it to exploit a problem and it goes off and does something else and then says you have a high risk vulnerability here, which is not the case. And I'm going to try and explain what the thought processes are at a vulnerability scanning shop that lead us to do these things. I'll say that I work for Detect, now BindView. We make the HackerShield vulnerability scanner. This is what I spend most of my time on, is these issues and how to best test for security problems in a real-world environment and what the constraints are. And I think that once you understand what the issues that we face are and how we build the tools, it's possible for you to be more effective in using them in your job. Knowing what you're doing and what the tool is doing makes it possible to use it better. And also, unlike the virus world or unlike the firewalls world, all of the vulnerability scanner groups are working in their own little company. You have a couple of smart people, they get together, they write a scanner. Occasionally at conferences like this one, we talk over beer, but we never really have serious engineering discussions about what we're doing or why. And I think that holds back the field as a whole. It makes it less likely that improvements in one scanner will get into others. It makes it less likely that the tools will be successful and used. So I want to talk to people who are doing this work. So how do scanners find vulnerabilities? What are the constraints? Why do we use these bizarre inference methods? Why don't we always just do exploit testing and actually go in and see if the vulnerability is really there? And lastly, I want to say that Greg Hoagland will be talking at 4 o'clock today on why scanners suck. It should be a very good talk, and I'm not going to focus on a lot of that stuff because he seems to have covered it well. So I'm just going to explain to you how we do these things. So taxonomies are, this is a taxonomy talk, and we're using a taxonomy because taxonomies are useful intellectual tools. When you put things into categories and those categories work, you can talk about them in useful ways. We can talk about what a script kiddie can do to your system. We can talk about what a professional cryptographer can do. We can talk about what organized crime or national security interests can do. And that's a taxonomy. It's a way of classifying things together so that we can call them a class. We don't have to talk about individual instances. So good taxonomies have strong differentiations between them. The periodic table of elements is a type of taxonomy and has these great distinctions. Everything is in a box, and those boxes are based essentially on electron shells, and the order of things and the position lets you infer all sorts of things about the elements. A bad taxonomy doesn't have very clear borders, very clear distinctions, but it's worth noting that even a good taxonomy that works really well for a lot of things has problematic items in it. And the duck-billed platypus is an example. The duck-billed platypus is a mammal. All mammals give birth to their young live, and they suckle them. Well, the duck-billed platypus is a mammal that lays eggs. In every other way, it's a mammal. It happens to lay eggs, but biologists put it in as a mammal. So sometimes taxonomies have these sort of border issues. So to talk about how these things actually work, there's two ways that most people will expect something will work. One is exploit testing. You actually run the exploit, see what the result is, and life is good. You know what the answer is with a good degree of reliability, or so you would expect. The other is banner checking. Satan did a lot of banner checking when it came out. It works almost entirely on banners, in fact, and a lot of people have said it's not a good scanner for that reason, and I disagree, and I'll go through why as I go through the talk. PHF is a classic example of an easy exploit test to do. There you have an exploit, you feed that to port 80 on a web server, you look at the result, you decide if it's a password file or not, and you decide what the result is. It's reliable. It's mostly non-intrusive. It doesn't leave core files on the system, it doesn't crash anything, it doesn't leave a big gaping hole on the system that wasn't there before, and it's intuitively correct. You look at a scanner doing that and you say, yeah, that's what the scanner ought to have done. And that's a challenging thing because we want scanners to work this way, and there are good reasons why they do not always do it. So Satan, as I said, uses banners. It looks at, for example, a mail banner and says, well, gosh, that's SendMail 4.1. It has this set of vulnerabilities. I'll report that it has all of these vulnerabilities. It's less intrusive. That's a really easy banner to change. In fact, I changed my banner, which I pulled off the system, from ready for mail to ready for exploit, and changed the date on it. This is remarkably unintrusive. There's no difference between a banner check and someone starting to send a mail message. So the effect on the system that you're looking at is very low, but a lot of people will worry that this is not a good method because it's an easy-to-change banner. It's not exploiting the problem. So is this correct? Is this acceptable? And I'm going to come to why the scanners will, in fact, use this sort of method. So I want to talk about terminology. And before I dig into the actual terms, I want to say that all of the language used in vulnerability scanners, vulnerability, problem, risk, test, check, is overloaded. These words have lots of meanings, and if I spoke Greek or Latin well, I might have used Latin words, but I don't. So I'm going to ask that you accept that I'm using common words in ways that have fairly precise meanings, and these are meanings that we have evolved at Netact and at BindView in years of daily usage. These are the ways that we have agreed to use the terms between us because having precise definitions helps. I'll also say that this terminology is not standard across vendors. If you go to ISS or Network Associates or WebTrends or one of the other scanner vendors, they will use different words to mean the same things. And this is one of those things that I'd like to start to change. I'd like people to start to use the same terms, because when we use the same words to mean the same things, we can communicate better. So, a vulnerability we use in a non-precise sense. It's a design flaw, it's a defect, it's a misconfiguration, it's a bad password, it's anything somebody can take advantage of. And if you talk to academics about what a vulnerability is, there's some great work that was done at Coast in really defining exactly what a vulnerability was and what you should and shouldn't call a vulnerability. And we've chosen not to use those definitions because it doesn't work from the point of view of building and writing a scanner. So problem is a synonym for vulnerability, and rather than use vulnerability, because it is such a loaded word, we often say we're looking for a problem. Or we're looking for a vulnerability. Why are we confident that the system has this vulnerability? We use test to mean an actual test, an exploit or other thing which takes advantage of the problem and says, you have this problem in a way that is a test. We use inference for any methodology that doesn't actually involve testing for the problem, but inferring that it's present. So the banner methods are all inference methods. Anytime we check a version, we check a registry key, that's an inference. We don't see the vulnerability, we see something which leads us to believe that the vulnerability is there. So in the sendmail banner thing, we would infer that sendmail has the debug problem on this system. So in exploiting a problem, again, we have the PHF exploit up here because it's an easy one. We actually think about this in terms of disproving a hypothesis. We will hypothesize that the system is safe. We will run a test. We will find evidence that our hypothesis is wrong and report that back to the user. One thing that happens in a lot of exploit tests is that you don't actually see the results so quickly. The PHF is a little unusual in that we see the result in the same TCP connection that we made. And on the next slide, I'll explain that there's problems like majordomo reply to, where you set up a mail connection, you send majordomo a message that has a bunch of shell escapes in the reply to field, and it will execute commands for you. That's really nifty, but you cannot see the results of the check in the same TCP connection. So there's issues of timing, there's issues of, did some other thing that happened on the system while we were checking it, while we were testing it, excuse me, cause this result? For example, if you ping the host that you're checking from, you've got your target, and you send back a ping in your reply to, well, maybe somebody else pinged your machine for some reason. Or maybe there's a holdup in the mail queue. The spool disk is full, and you won't see that ping for 16 hours. So there are multiple types of exploits, and as you get into actually looking at the exploits, you see that many of them, you can't actually directly see the results. And that leads to a loss of reliability and a loss of effectiveness in doing a test. So I talked briefly about hypothesis. Tools will both assume that there's safety and assume that there's risk. And both of these are legitimate, effective methods, but intuitively, there's an assumption on the part of a tool user that the tool is assuming that there's safety and going out and finding evidence of risk. You expect when you see your tool come back and say you're vulnerable to this, that the tool has gone out and found evidence that that is the case. There are times when the impact of a test is substantial enough that it makes more sense to look for evidence to infer that the vulnerability is there or not there, and assume risk and try and disprove that. For example, if there's no mail server on the system, you can reasonably well infer that the system is not vulnerable to a majordomo reply to bug. And in that case, what we're doing is we're really assuming that there is a risk and finding evidence that that risk does not exist. And this often surprises people when they first encounter it. A lot of people, especially the kind of people we hire to join our security team, argue with this quite extensively because it's intuitively wrong. You really want to be able to say, yes, we found evidence that this isn't safe. You don't want to do that, but we've come to a conclusion that we're comfortable with, that assuming risk and looking for evidence it's not there is an effective and valid technique. Yeah. So oftentimes when doing an exploit test, people will want to look at banners. And looking at banners is an interesting thing in exploit tests because it really boils down to our cheating and not accepting a strict definition of vulnerability. At the bottom of the page here, we've got two different definitions of a vulnerability. One is a web server gives out source when %20 is appended to the URL. And the other definition of a vulnerability is the IIS web server gives out source when %20 is appended to the URL. It's not clear which is the right definition of the vulnerability. Which is the right definition of the vulnerability actually has an effect on how you test, because if the right definition is IIS has this vulnerability, then you need to check that IIS is the web server in question, and you won't see the vulnerability on another system. Whether or not to do this really boils down to an academic discussion of what a vulnerability is and how to define it. And you'll see, even within tools, inconsistencies about what they do, because it's not a settled argument. And as tool users, you need to understand that this sort of thing may happen from time to time. As a vendor, we'd like to give you better information about what we're doing and why the tests come out the way they do. So one benefit of doing this, doing these banner tests and why we do them in various exploits is because you reduce the impact of a test by only testing on a system you expect is going to be vulnerable. If another web server, little web server that you've never heard of, crashes when given that %20, you're going to get a call from an angry customer whose web server you just crashed because you were doing this vulnerability check, which you thought was a legitimate thing, which wouldn't crash anything. And so sometimes you'll insert banners to reduce the denial of service effects of tests. It astounds me, even being a very cynical person with a very dim view of software quality, it astounds me how many things crash in bizarre ways when you run a security scanner against them. An X terminal that will crash when you connect to its SNMP port with an empty request. HP printers will go down when you port scan them. The TCP stack just can't handle rapid successive requests to different ports. So what a vulnerability scanner does when it runs tests is it's trying to violate the security of the system. We are trying to do things that the implementers of the code didn't expect would happen, and that often causes weird things to happen. You can leave core files, you can fill logs. Some exploit tests I've seen will add root accounts, which is one of those things that you as a customer probably really don't want to have happen to your system as we're running a test. It'll make copies if we need to read a file. We need to read etc shadow to demonstrate that a test actually works. Then all of a sudden, we've got a copy of etc shadow on our host. We may delete it immediately, but parts of it may end up on the swap file or in other places, and that's a violation of your system security. You don't want us to copy that data off of your system because you'd like it to stay secure. You'd like it to stay on that machine. But at the same time, to do the intuitively correct thing and test for the vulnerability, we have to go and get that file. We have to be sure that that file is present, that we can read it, that we can analyze it. And so this conflict, this tension, is one of the things that leads us to use inference testing methods, or excuse me, inference checking methods, because people come to us and complain, gosh, this vulnerability scan crashed this service. It left my machine in this funny state. I'm not happy. Make it less impactful on the network. Make it less aggressive. And so Without even talking about how to test for denial of service problems like teardrop and land, we're going to come to using inference methods because people ask that we not engage in this destructive behavior on their networks. And that's legitimate. You want to be able to test your network without spending a week cleaning up after yourself. Denial of service testing is fun. With daemons, there's sort of two ways you can do it. There's the connect, attack, and then reconnect. And if you reconnect it, it's not vulnerable method. It doesn't work if your system is under inetd, and denial of services against inetd spawn things are fun because you can often absorb memory, create core files, stop the service for a little while. And it may also fail because of other reasons. We've seen firewalls that have some intrusion detection stop this sort of thing. We've seen machines crash in between the time that we do our service denial of service check and try and reconnect. The host will crash for some other reason. The reconnect fails, and you believe there's risk when there's not. So a lot of these checks will look very carefully at the way a connection ends. The semantics of TCP when you crash a service are very interesting and very dependent on how the service is running, what sort of watchdogging there is. And we've had customers ask, well, how can you know that this service is down? You didn't bother to reconnect. This is how. We watch the connection very carefully. We look at the TCP flags. And a reset plus push almost always means that we crashed your service and something above it is giving us a response. inetd is letting us know that the connection is no longer there. Whereas a fin will usually mean that the service is just shutting us down. Yeah, the some daemons die on connect close. Strobe found a bunch, Nmap found a bunch. Just running through a machine, you discover, running through a machine twice, you'll discover you get different results. Services will die off when you're doing this port scan. And the other thing that makes denial of service testing very difficult is systems often fail for reasons unrelated to the particular test that you're doing at the time. And you'd think, well, you know, you're doing a scan, it takes a few minutes to a few hours. How likely is it that a system will die? Well, when you deploy lots of vulnerability scanners against lots of systems, you end up finding lots of situations where a system fails for reasons completely unrelated, but you get blamed for it. Was that a production server? Oops. We really try to avoid this. We try really hard. It absorbs a lot of time and energy, but it happens. And it happens because we're doing things that the software doesn't expect. Sometimes it happens for reasons wholly unrelated. We had an interesting one recently where somebody scanned about 24 machines, and mostly NT machines. In the morning, 3 of them were hung, and called up to yell at us, and we asked, well, how many of your NT machines usually hang over a given night? And the answer was, well, 1 or 2. And the person wanted to blame us for all 3 being down until they really thought about what the reliability of their network and services was. So we come to less intrusive methods, and there's two large types of less intrusive methods. And those are the inference methods, which I've talked about a little bit, and credentialed methods. And I'm going to go through the inference methods that we use and then talk a little bit about credentials. So if the exploit will crash the target, if the output can't be reliably parsed, this is actually an interesting challenge. There are some really simple services which vendors love to muck with. Finger was the first example that really struck me. If you try and finger a user at a given host on a dozen Unixes, you'll get back between a dozen and 18 different response formats, which you need to parse reliably in order to say that finger is turned on and not just producing a banner which says we have no information about this user or we've turned finger off. And then you hit your 14th version of Unix, and the check no longer works. So that is an example of a place which most of us have probably encountered where actually writing a reliable parser to declare that this thing is doing something that is obvious to a human observer is a little on the difficult side. Exploits are still secret. There's a lot of exploits which are discovered by companies and then not disclosed. That not only means that you can't get them to play with it, it can mean that we can't get them to play with it. There are a number of scanner companies which publish exploits very regularly without the details and then do not share those details. So in those cases, people need to use inference methods. They need to use methods other than an exploit because the exploit is not available. Exploits can violate the rules. I've done penetration testing work where we were not allowed to actually exploit any problems. We had to say, what can you see when you go and look at the system without exploiting anything? Well, you end up doing a lot of inference work then. Another thing about inference methods is that the distinctions here are more clear-cut than they are in the exploit methods. And that comes from the fact that here we're doing things of our own design to infer that the problem exists or does not exist. In exploit methods, you're forced to do something that approximates an exploit, and exploits are messy. They're written in a lot of different ways. The way they actually function varies immensely, and it's hard to put lines between the various exploits and say, we divide them this way and this way. With inference methods, because we're in more control and the things we're doing are more classifiable, we have more clear-cut distinctions. Versioning. Versioning is sort of a superset of banners. It is, you ask the program what version it is, it gives you an answer, you make a decision based on that answer. It is really actually very effective when the banner information is hard to change. To change the banner information in named, you need to go in and edit the source. Same thing with SSH. Sendmail is a different story. You know, if you can just go in and understand a Sendmail CF file, which is a little difficult, you can change the banner. I just wanted to point out here that usually what will happen is we'll use a banner matches some regular expression, and the version is less than n. And this generates a set of false positive results where we'll see a version which is so old that we don't actually know if it's vulnerable. We'll declare it vulnerable. You ought to update it. And people will complain, you know, oh, that vulnerability was introduced in version 3 and we're running version 4, so it's got other vulnerabilities, but not this one. Not having access to version 3, not wanting to check every back version that might exist. Generally, the way the logic works inside the scanning programs, and here I can say this is not just ours, this is all of them, because we've done competitive analyses to see how they work. Almost everybody uses a banner matching and version less than method in doing some of their version checking. Port status checking. There may be, the way this works is you try and connect to a port and then you declare that there's a risk there. Sometimes the risk is that there's something listening on the port. You know, if your policy is we only allow SSH into this machine and there's another port open, then the fact that the port is open is a risk. You can also use this when additional probing is not likely to reveal any more information. There's a lot of RPC programs, Mountie being one of them, that has a couple of buffer overflows. And we can crash Mountie for you. That's pretty trivial to do. But we can only really do that once, and we don't learn a lot because most versions of Mountie can be crashed with similar exploits. So if we see an RPC Mountie listening, we may declare risk because anything going beyond that is simply too intrusive. And This sort of checking gets really interesting when you're trying to do it through a firewall, when you're trying to do it with UDP. You send off a UDP packet, nothing comes back. Well, did you get a port unreachable that was swallowed by the network? Was there something there? And a lot of times you'll end up sending multiple packets to try and get a response from one of them. Now, this becomes difficult when, for example, your SNMP daemon dies when it gets an empty trap. So there's this tension which constantly exists between doing a lightweight test and doing a very reliable test, and the effect of testing on a system which is not robust. Your system shouldn't crash when I do this, but if it does, then not only did I mess up your system a little bit, but I give you bad results. So one of the things that I'd like you to take away is an understanding of that tension and that difficulty which people making vulnerability scanners are dealing with. Protocol compliance as a means of finding risk. You exercise the server a little bit more than port status. It becomes a little bit more intrusive, a little bit more reliable. You declare vulnerability based on the results. If your policy is no web servers, then it's very effective to get index.html and then declare risk. This is a valid way to do a test, and if there are services that you don't need running, a lot of the checks will simply say, oh, yep, this looks like an echo service, you ought to turn it off. Behavior gets a little bit more complicated, and a lot of times it tends to blur into exploit testing. What you do here is you examine the edges of the protocol to see what the implementation of the software is. For example, Qmail, when you connect to it, has a very distinctive help message which tells you about Qmail. Whatever you'd like to do to the banner that Qmail produces, it's unlikely that you're going to go in and change the help file. So we use the help command to get more information. Qmail also has some distinctive error messaging that it uses. Various other mail servers will implement verify and turn and ESMTP with different responses, and you can learn a lot about the family of software that's running by exploring this sort of thing. And if you can demonstrate that the software that you're examining works differently than the software that you know has a risk or a vulnerability in it, then this is a reliable way to say this software does not have this vulnerability, because to produce this set of behavior that we have in front of us would require that the user go in and modify a bunch of things which generally are seen as not mattering and ignore the vulnerability in his system. So we consider behavior to be a reliable way of working. Credentials are a level up. Credentials are at the same level as testing and inference methods. And it's a generic way of talking about logging into the system before making your determinations. Unix login and password, NT account names, passwords, and logging in on NT, for those of us who come from a Unix background, is a little weird. You send the credentials as part of various API calls, and the server evaluates them. Credential checking doesn't include public. SNMP traps that are public are not really credentialed. They're public, anonymous, guest accounts. We don't class as credentialed checks. Credential checking is very non-intrusive, except when you install. When you install, you need to collect up these credentials. You need to install software on the machine. And that's a royal pain. It's really very reliable stuff, though. If you can log into the machine as root, if you can connect as administrator, you can learn everything about the system and go into lookup tables and say, this is configured wrong, which leads to this vulnerability. That's configured wrong, leads to this vulnerability. And there's a bunch of ways to do that. You can ask for software version information. You can MD5 files and then compare to lists of known good or known bad. You can call various APIs to gather data. PS, netstat, some various SMB things on the NT side, and you learn an awful lot awfully quickly. And most scanners will try and do some things with credentials from time to time. In conclusion, I've tried to go over the techniques that we use based on exploit techniques, based on inference techniques, based on credential techniques, so that you have a high-level understanding of how these tools work, why they work the way they do, which is often hard to understand until you've been through it a lot. I've tried to go over some of the pros and cons of the various techniques and explain why we do them the way we do them. And again, this is a work in progress where I believe there's a lot of interesting work left to be done. Scanners are not the greatest tools in the world today, and I think understanding these techniques, talking about how they work and why they work, how to enhance reliability without enhancing the intrusiveness, is something that I hope will come as people think about these in more rigorous ways than they have. So, are there any questions?
In defense of your own technology, though, one of the things that as these scanners are emerging and these technologies are being adopted by organizations that is big in the companies, that something when it doesn't fall on us as vendors to try and build these web mousetraps, but also as you said, there's for example, an inconsistency in scanning twice. Don't you think some of that only falls back on vendors, on the application vendors themselves to realize that we are looking at this from a security perspective, not a performance perspective, which forces them then to change their own paradigms? Very early technology.
Right. The question is how much of this onus should fall on the vendor versus how much of the onus should fall on the user to make good use of these tools. Is that a fair restatement?
No, it's more so targeting the vendors themselves and saying, I'm not talking security vendors, I'm talking application vendors to say, look, people, you're looking at this from a whole viewpoint for the sake of the end user. You have to look at it from a whole there's a major disconnect there. I mean, that's not part of the profitability structure today.
Yeah, absolutely. The disconnect between what application vendors are doing and not offering security tools or not offering security and reliability in their products, I think, is something that needs to change, and we need to see vendors who build applications, building them more reliably, more securely, and more generating less need for this sort of tool. But I think that there is still a place, there'll always be a place for looking at your system from this perspective. But if you build other tools, think about what happens when people do this sort of thing, not because we as scanner vendors do it, but because the bad guys do it a lot. Yeah.
It seems that the approach that scanning companies are getting into now is the kinder, gentler approach to, well, you may have a problem, but you might not, which kind of goes away from the whole reason why I want to buy a scanner. I mean, I want to buy a scanner so that somebody else can, I'm willing to pay you to do the work for me, to tell me where the exploits can happen on my system so that I can make them better.
Right.
But a scanner, a scanning tool which tells me, well, you may or may not have a problem, and it doesn't lead me to any other way that I can continue to focus on how to relieve the problem if there really is one, right? Or is it, well, is that worth the money that I'm paying?
So the question is, shouldn't a scanner go out and actually exploit the problem, actually get the results so that we give you a definitive yes or no for each issue, because that's what you'd really like to see?
Well,
and
the hacker community doesn't care whether they crash my production box.
Yeah.
And if a scanner refuses to do particular tests on a production box, then I have no idea of knowing whether or not it's vulnerable to that kind of an attack until someone actually does it, and then I'm in trouble.
Okay. we'd like to be able to give you a tool that will actually do all of the tests if you would like it to do that. What we have found is that most people do not want that. And one of the goals that I have for doing this work is to be able, in our descriptions of the tool, to say, you know, show me which checks are working by inference methods, and then upgrade as many of those as possible to use full exploit methodologies, to use the most aggressive methodologies to give you the results that you'd want. But that's very difficult to do when the customers don't understand how the tools work. And because if I put a slider in the tool that says reliability versus impact, people will just yell at me for that because they don't understand why that is.
But this are the same people that are going out and purchasing operating systems and whatever off the shelf and installing it right out of the box and putting it into production. They're exactly the same people that are doing that are complaining that the tool is hurting their system. And so what is actually happening is lowering the bar as to what is actually security, and the scanners are actually becoming a part of the problem. In my point of view, my personal opinion.
The opinion is that it's scanners, by acquiescing to the demand for not doing this damage and not aggressively jumping in like this, are helping to lower the bar and make systems less secure. I don't think I agree with that overall, because I do think that using a scanner is a useful thing, but it's an interesting viewpoint. Drew?
Well, back on what you just said, though, if that's true, and I can't review, I'd like to hear more on that. If that's the case, and if there is an argument to be made for that, it actually ties right into what Mike was saying this morning, and also what I was saying earlier. It sounds to me like vendors, security vendors, based on your that security standards, software, kind of whatever, are now, as you said, acquiescing to the fact that the victim organization, the customer, if you will, is intolerant of the idea of scanning a box and bringing it down and blaming the security vendor rather than blaming the operational vendor, the operating system vendor. So they get a picture that it's not our problem, it was their problem, because they didn't build the security and they build the productivity. That's a big argument that we can solve in this conversation.
Yeah, I'll agree with that. Sean?
I would just want to make a comment on that, and that's the fact that these vendors are providing us tools that go in a toolbox. One of the biggest problems that I see in the community out there is that they can't find the security professionals to look at what they're running the tools from. So you have to realize, I mean, all of us in here, the more hardened you make your box, the worse the scanner works, because banners have been removed, or something like package info has been removed. All those pieces that start being removed, the inference features are going to fail, and they're going to say, well, we believe this is unsecure. So the testing here that we're talking about, the vendor is doing us justice by telling us that we have the inference method. It's up to the security professional at the organization to say and get management to believe that they need to run the full exploit test. And if they're worried about them, they do take backups of all your systems every night anyway. You can take one of your QA boxes, build this, and run your tests in this QA box. It gives you a better outline than when you run the exploit.
It's a good point that you, one, you can run against a backup. Two, that by giving you the information, we're offering you some choice. One thing that I want to say, though, and I may not have stressed enough, is there are times when you cannot test for a vulnerability because the result of running the test is not observable in an effective, reliable way. And the majordomo reply to is an easy to understand example of this is a test which may fail if, for example, you've removed ping from the system but majordomo is still running there, if I'm going to send myself a ping of a bizarre length so that I can see the ping come to me, if I have the path wrong or you've removed the command from the system, even running this exploit test is unreliable because of factors that are going to be very difficult for us to see. And so this goes back to me saying the exploit test is intuitively correct. You want to do that, it feels right, it feels correct, but there are times when, even when you're going to ignore the impact of the test on the system, or you're willing to accept the impact of the test on the system, it still is not reliable. And there may be other methods which are more reliable, even though they don't do an exploit test.
One of the questions about behavioral analysis and how you use it that occurred to me is, are you testing for behavior of known products and provisions that have known exploits? Or are you testing for behavior that indicates fixed versions?
Okay, question about behavioral inference. Do we look for a known vulnerable version or a known fixed version? Generally, we use behavioral methods as an adjunct to some other sort of test to reduce false negatives or false positives by saying, you know, this is Exchange server, it just doesn't have this vulnerability, which we're not going to test for because we can't see the result. So we'll eliminate Exchange server, we'll eliminate sendmail, we'll eliminate Novell mailer, and what we have left is probably vulnerable.
So if you set up burglar alarms in your system by modifying things like lease and send, etc., the banner approach would then fail because you might get the same banner. The banner hasn't been modified.
Yeah, burglar alarms, deception toolkit methodologies, honeypots, scanners will fail. And not only the inference methods will fail, but if you've got a good piece of deception code, and we've got some great deception code because we use it in QA a lot rather than reinstalling various broken software, you can make an exploit test appear to be successful. You can have a bit of deceptive code on your box, which when exploited will pump back a fake password file. You can have a PHF trap, which will send out a fake password file. And it is really remarkably difficult to demonstrate that you have deceptive code rather than the actual vulnerable code. That's the point of your deceptive activity. And the more successful your deceptive activity, the more failure prone the scanner is going to be. And I'll in fact argue that the scanner is succeeding where it falls to your deception because you are intentionally trying to make it look like it's vulnerable. We say it's vulnerable, you know, what other result would be correct? Yeah, I'm going to take one more question and then head for lunch. Uh-huh.
What was that an indicator of? I notice I'm getting that on some FTP transactions when a PC tries to scale back the window size of the transaction. I'll end up generating a reset push.
Okay, question is about reset push, and you've got a problem with an FTP server generating that when a Windows client tries to resize the TCP window. Usually when we see that is when, for example, a CGI dies in the middle of the CGI because you've done a buffer overflow attack on it, or something running out of inetd dies. You'll see this reset push. I suspect that what's happening in this particular case that you bring up is that the server hasn't implemented the TCP resizing stuff correctly and is throwing back a bogus result, and that's actually a great example of one of the difficulties that we see in doing an exploit test is that, you know, we're doing A, B, and C, we need to resize the window, and if your FTP server software, the TCP stack on that, sends back a reset and push when we start playing with window sizes, That makes it very hard to actually observe what's going on because this bizarre behavior is happening, which I've never seen. I'd be curious where that is. So I don't know what causes it. I would suspect it's bogosity in your server stack. Alrighty. Well, thank you very much. And